We continue with the advanced textile printing, in which we are talking about inkjet printing. So, what we learned last time was that the grayscale can be controlled by the size of droplet. Resolution is more dependent on the print head design and the requirement that we have. Print head by itself is very complex from electronics point of view, from the actuators that you use, whether it is thermal or piezo, and we just saw that a normal inkjet printing machine of course is a heart and main machine, but it is supported by a feeder, dryer and so on and so forth. And now we are looking at the possibility of one pass inkjet printers. What it means is that your printing head and the carriage is going to be stationary, and so the speeds can be very fast. We will spend some time on the cost of this printing. So, we say that the main difficulty people have been facing is the cost, that we discussed in the early days, that the percentage of production happening via this technology is quite low. We hope that it increases in coming future, and one of the thing which has been responsible is the cost. While as the speeds of printing are increasing, and if you look at one pass type of machines, then we may expect the cost to be very, very low or absolutely comparable to any other technology. And once that happens, then life will be different. So, today the situation is that if you are having smaller print runs, 100 meters, 500 meters, this is still cheaper. But when we have long runs, 1000, 5000, 10,000 meters or more, then a screen printing, the conventional screen printing may be cheaper, because the investment done to prepare, design and screens and storages and so on and so forth becomes compensated, it gets compensated. The cost of a digital printing system, which is the inkjet at the moment, is basically constant. So, if it is a very, very small, you are going for piece goods, then maybe it is a little higher, but after that it does not matter. So, you print more or you print less, the machine ink that is required is based on the design. If design remain constant, the ink cost of the ink may not change at all. Yeah, of course, there will be something else to be considered also. So, that is the advantage of this, and if actual speeds become high, and the only thing which you want to compare is the screen printing, roller, flatbed, screen are not so, let us say, attractive. The rotary screen is definitely very attractive till now. So, the cost of the printing depends on the print coverage area. 20% coverage, rest is blank, versus 60% coverage, and that has something to do with the ink cost. You will be using more ink. As such, you use very less amount of color. I mean, your wastage is very, very less of anything else. Most of it, whatever is like a part of a drop, has some other solvents and chemicals, but mostly it is ink, and the ink is concentrated, and so it is used. So, it is effectively based on coverage, the cost due to ink. Ink by itself is costly, that is one part, but it is required very less also. Machine cost You bought whatever you bought, initial investment, that is one part, and so that remains constant, and obviously some project would be having break even values, but it does not change. The only thing that one has to consider as a recurring cost other than the ink is the head. The print head can get damaged, they may require replacement. There is no repair actually. It is very difficult for someone to say, well, something has gone wrong with the print head, unless the top connection only, but inside something has gone wrong, something is choked. So, you do not have a system to clean orifices and then say, well, start using it again, that is unreliable. So, it is a replacement is the one which people work, and so it is a print head and ink combination, and some print head is good for a certain type of an ink, and if the ink and they are compatible, the life will again be high. If you use a ink which is not recommended by the print head manufacturer, will you say, well, it is okay, what is there, it is just a reactive dye and we can make our own ink, or somebody else makes an own ink, and you say, I will use this company's ink. So, you may be lucky if everything goes right. If everything does not go right, then this combination can also be responsible for additional costs that you will be incurring, which is nothing to do with, of course, something to do with the production, that after a certain amount of production or certain amount of use, something will have to be changed. So, print head cost determines the cost of the machine also. Very sophisticated things where everything is being controlled, how many nozzles are there, what operating frequencies you work, all that makes the print head itself a very costly item. How the ink is being fed, how many stations are there, whether it stops at left and right both, or it stops at any one point, how many carriages are there, how many heads per carriage you are carrying, all that becomes costly. So, actually whether you call it cost per nozzle, you have the operating frequency which is very high, all of that actually is a substantial amount of cost, and if you have to replace this, so it is not like replacing any other small part of the machine, it is actually one of the bigger part of this therefore becomes a concern. And so, people would like to buy things from very standard companies, and so sturdiness of a print would be always very important. Why will it fail? It can fail for various reasons, maybe filtering is not good, maybe something else has come up, or maybe the ink and head combinations are not good. So, maybe we had talked about it before, that is like thermal inkjet, it can fail because there is a heater, and for various reasons there may be deposits on the heater surface. But that is part of the thing, is understood something will happen. If that is the only reason why it is there, you will still be okay, because once something is deposited, thermal conductivity changes. Other is the corrosion of the heater surface, bubble formation and collapse, etc. They can also cause failure of the head, and so you may require replacement. On such type of matters, the piezo based system is more controlled, more robust, frequency is less, but that also means maybe production is also not as high and you will like to have something else. But this type of compromise on one or the other technology people will be doing. You may not really be interested in trying to save any cost on the ink, because ink used is very efficiently is being used very small, but people may try and compromise on these things depending upon what is happening. So, general strategy is that the machinery manufacturers may be different than the print head manufacturers, because here the technology and complexity is much more in a print head compared to the rest of the machine, where you have tension control, feeder control, speed control, temperature control. that is something else. Of course, they appreciate what is happening. Machine may have, of course, softwares which will understand things. So, and then the ink manufacturer. So, basically all the three actually are collaborating, that if my printer has got this kind of a head, then this company will definitely has understood your requirement of the head. And so, it is not that it is a magenta color, it is actually suited to this type of a print head technology. And so, they exactly study each other and they manufacture. So, it is a collaboration work, and what it says is a warranty. In case you are using somebody else's ink, then the print head warranty may not work. So, you may call it monopoly, but it is called collaboration. So, you say use my ink, use my printer, use my machine. So, one machine manufacturer uses one type of a company which makes print heads and does not have to look, give me any print head, I will just attach it and start using it. Theoretically it is possible, but because the overall cost of the machine is high, we do not want to take such risks. So, whichever is the machine manufacturer, he or she, the company has to make sure the arrangement with the print head and also recommend what ink. And if you use all that, then the warranty clauses are more meaningful. So, going further, the ink and the related process. So, general, the acid type of an ink category would be suitable for silk, wool, nylon, but may require a pre-treatment, may require a post-treatment. In a pre-treatment, you may have some acid latent or otherwise being there. In post-treatment, steaming, washing, and of course, drying. Reactives generally initially were recommended for cotton and other cellulosics, but theoretically we can use them for wool and silk, and if they are being for cotton, you will be requiring an alkali, and if you are only for wool and silk, you may actually not require any alkali in a pre-treatment and it can still work. Of course, steam and wash you may like to do. Disperse for only polyester, but actually theoretically you can use it for nylon as well. You may not use it. You require just some kind of a thickener and possibly some amount of dispersing agent maybe. So, high temperature steam could be one of the ways in which you do it. The pigment can be used for all types of fibers and actually does not require a pre-treatment, but you may still give some treatment to make the surface better, and post-treatment would be only dry heat for curing purposes because there is a binder there. So, there are definitely less number of manufacturers who do this formulation for inkjet printing. So, all the dye manufacturers are not the manufacturers for inkjet printing. So, other than the type of color, the chemistry of the colors, but there is a formulation which, as I said, could be based on the type of print head somebody is using, and therefore, you may be recommending. That is why. So, some big companies would be making all types of inks. So, you can have reactive ink for cellulosics or acids or disperse for transfer printing, because transfer printing has not gone out, it is still there. So, you print paper, or directly you can print polyester, or disperse inks which are for polyester only and not for transfer printing, and pigment inks. So, they all make this type of a formulation which will be available. So, one thing which we are almost realizing is that all in one ink, that means you add everything in the ink, likely to have a low storage stability, that either you use it very quickly or do not use it. throw that off. Like reactive dyes and alkali, if they are present in the ink together, then there will be a problem. So, you will not do that. Other chemical ink, you put it in the ink, could be corrosive, like globe salt or a sodium chloride. And particularly when you are using a technology in continuous inkjet printer systems, where drops are charged, they would require low electrical conductivity. If you have ions in the ink, then there will be problems. So, for various reasons, you may not like to put everything in the ink. Thickeners in the ink may not have the required rheology, because you require low viscosity. So, if at all you require some way to control diffusion, then again it is not a good idea to have any of such thickeners very easily in the ink. So, rheological properties will be affected, but rheology which is required is of low viscosity systems, but still have to be controlled. As we mentioned earlier, that the inks will be highly concentrated solutions of the or suspensions of the dye or a pigment. So, if salts are present other than corrosion and other thing, they reduce solubility of the dye, and so particularly in the aqueous systems. So, all in one cannot be considered as a good idea, and so we are working on what we call as a pre-treatment. So, we remember that from the inkjet point of view, photo image point of view, the transfer printing was a clean technology. That means the thickener was on the paper, nothing to do with the fabric. Dispersed dye would sublime, diffuse into textiles. No further fixation or wash off was required. So, very attractive, except that the cost of the paper and what to do with after using the paper was the issue. And another issue, of course, that natural fiber fabrics such as cotton, wool, silk, the transfer printing was not viable. Of course, we thought about wet transfer printing, but commercially has not been very successful, and most of us use all types of fabrics, and therefore, this is not a good situation. So, direct inkjet printing onto textiles can be done by sublimation dyes also, but again on polyester. And so, as we understood that for different other textiles, you may require different class of dyes, and that would mean that you have to modify things. As far as the fabric is concerned, you will modify the surface, so it becomes smooth because a rough surface, it has been scoured, bleached and maybe mercerized, and so the wetting is high, which obviously was required initially. But for printing purposes, you still have to control the diffusion of color in transverse direction. If it goes inside the fiber and into the fabric, you do not mind, but if it goes laterally, then there is an issue, and this is because of whatever capillaries and so on and so forth we have, and in some sense was a good idea. For printing, you had to control, and you require for different things, chemicals etc., for fixation and diffusion, and so you would require what we now understand is pre-treatment. So, this is obviously making this process not as clean as the transfer printing. So, everything is to be done. It can be very complex also, other than the, except that some beautiful designs cannot be produced by any other technology, and therefore, all complexities you will like to tolerate. But if it is a simple design, some checks and some dots to be printed, You might just say, well, this is as complex. You first do the pre-treatment, then you do the thing, and then you do the post-treatment. Why should I be interested in this technology? So, that is one of the reasons also, is complex. So, thickeners and chemicals, when applied separately, are expected that they would control the wettability and penetration, and so your designs are going to be there. So, that is one reason you may like to use thickeners even for pigment printing, pigment inks. So, capillary forces are going to be controlled by some kind of a thickener layer which you apply onto the textile. So, generally for cotton and cellulosics, reactive inks would be suggested. Just typically, this may contain sodium alginate. We know that any other thickener is not good for reactive dyes, so you may use that. Urea may be required as a humectant to ensure that while you are processing, when everything is dry, there has to be a moisture, and so diffusion should take place. And some alkali. When this alkali is there on the fabric, when the dye comes, hopefully this is the only one which will be varied. So, at a concentrated area, alkali will be available. So, hopefully reaction would take place only with the fiber. You may use a resist salt, which is a mild oxidizing agent, as you know. During the fixation process, when you are going to be using steam, you should be able to control any damage due to reduction. So, what you do? You can pad through this type of a solution the fabric, or you can overprint it. If you're not, if it's a thick fabric and you don't want so much chemical to be used, you can just put it on the surface. That's no problem, but padding is cheaper. And of course, you dry. I mean, you're not going to be taking a wet material inside the digital printing system. So, all this is important. So, whatever cost it has and whatever complexity, you have to do it. So, wool would require, can be dyed by the acid dyes, which is normal case, wool and silk, because the color gamut that is available looks pretty good, although reactives also can give similar effects, but acid inks are available specifically for wool and silk. If you do the acid, you will not use obviously alginic acid or alginate, because in the acidic environment it coagulates and you can have difficulty. So, one of the interesting thickeners obviously remains is the guar gum, which is okay. You do control molecular weights in a manner that during washing later you should not have difficulty. So, the only thing which you would be concerned is now the thickener is everywhere. In a normal printing, the thickener is only in the printed area, and now thickener is everywhere. So, its washability has to be good. It should not obviously change the handle or remain some percentage of thickener has not been washed. So, that means it is going to be there. The acid normally, obviously in these cases you may not be using mineral acids, sulfuric acids and so on and so forth. So, organic acids could be used. In this case, the example is in some sense a latent acid. So, it is an ammonium salt of a tartaric acid, which at the fixation stage, otherwise the ammonia will go and tartaric acid will be there to do all the job. Padding obviously can be done, and as I said, alginate should not be used. Nylons can be printed in the same way as the wool and silk. Same acid dyes can be used here. Some optimization because of the diffusion rate into the nylon versus into the silk and wool, which are more hydrophilic. will have to be done, but that is one part of it. So, wool, silk, nylon can also be printed with inks containing reactive dyes. So, you do a pre-treatment with them. So, if you use reactive dye, then alginate will have to be used, which is in some sense you can call it migration inhibitor. Ink will not be allowed to go beyond the boundaries, and so like whatever reason you had for using this on cotton reactive. Polyester, theoretically anything can be used as long as you are quite sure it is going to be washed. Generally the pH is safe, so synthetic thickeners can also be used as long as you are able to control their viscosity. So, because you are going to be using high temperatures, so because of urea vapors going here and there and all kind of things, you may use or may not use urea at all, or use very less. Although there should be some dispersing agents in the ink itself, but you may put something during this padding process as well. If you have blends, so as of now a mixture of dispersed reactive inks is not available. The reason is you do not know what blend you are going to be working on, what ratios you should be making, and then of course there will be differences. So, the best thing of course remains, if you are very looking at blends, is pigment. And if you are wanting everything to be nice, because the fabrics could be very thin, could be very thick, could be very rough, could be knitted or woven, all those kind of things. So, some amount of thickener may be required to make sure the fabric dimensions are controlled, and so that you may still do, even with the pigment, some amount of padding and drying of course.
Binders used in blends, padding of blends, binder may be used?
No, a bad idea, because binder will not be washed off, and so the handle of the whole of the fabric is going to be changed.
Then how the pigment will be attached to the?
All right. So, pigment has a binder inside, and therefore, the ink head, print head technology that you will choose will be such that does not get a problem. For example, thermal inkjet you will not like to use with pigment inks, and you may in such cases have the catalyst which may be outside, right. But as far as the binder, you do not go to pad the fabric with a binder, that will not be done, because that is the limitation. We anyway are not very happy padding everything with the sodium alginate where the print is not to be there. If 20% of the coverage is there and you are still printing or padding the whole of the fabric with the thickener, so it is a waste in some sense, but it is very difficult to do anything otherwise. So, this is a challenge. I mean, this challenge is not finished to this extent. Today you are doing it, tomorrow if you can have any other better system. So, the only thing you will say, well, what is required is no longevity is required, you just pad, bring to the printer, finish it off and wash it. So, washing capabilities should be higher, and so there may be relatively low molecular weight compounds that will be preferred.
For polyester we are using sodium alginate. We may use
anything. Theoretically you can use anything, does not matter, as long as you are saying this does not harm anything. The cost of this is almost anything you can use. Guar gum can be used, no issues. So, we just not go into details of this too much today. We will discuss some aspects and then we will stop for today. The pigment inks are relatively were one of the more popular ones to begin with, because this actually gave the real advantage of printing with inkjet. Even if you do not pad, you can still print. You can take any fabric and just print, as long as this is under tension and no way it will touch the print head. If that can be ensured, you can print. And after that, you only have to dry, which of course you have to cure the pigment. That's the only thing, but you don't have to wash it. So after wash is not required. So it is almost like transfer printing, but in slightly different ways. And the other thing was that you didn't have to bother which fabric blend are you worried. A lot of people have been using this for garments, piece goods, and just take it, print, finish. And so pigment had been very popular, and one of the first inks which were designed were these. The only thing was you had to design the binder which had very low, let us say, glass transition temperature, and would not very easily clog. So it had to be dispersed very nicely in the ink. The binder, as we said, cannot be used outside. This had to be inside. So technology had to be decided, which of course was non-thermal piezo based system and binder. So that is the difficulty which people, dye manufacturers and ink manufacturers face, that you not only have to make a good dye, but you have to make a good formulation which will suit a particular technology. And so it became more and more complex.
So what will happen if I use binder in thermal inkjet?
So because of the heat, this is a type of a monomer ready to be polymerized. So if it polymerizes within the ink, because or around that heater, even if little bit, and then goes, chokes the nozzles, so your head goes.
As you said that no further fixation is required for transfer printing, but in case of wet on wet transfer printing, there may be required.
So when we are referring to transfer printing, we are referring to polyester and disperse, because the others have not really become very popular commercially. So if there is any competition between inkjet, this is with the dispersed polyester combination and not with any other, because they are not there. On the other hand, inkjet is now available for acid reactives and pigment, now we are just discussing. So technology wise, people feel that this is more versatile, complex but versatile, but it can give you results which other technology may not be able to give you at all. And so there is an interest that we look at it. So this is, we start with an advantage and not look at the disadvantage first. So all substrates and simpler process, piece goods, garments, everything can be printed through a pigment ink. So this ink also, and all other inks, will be working at low viscosities. So that is one part. So whether you make a suspension out of it, it will still have to be low viscosity. But what it means is that even at low viscosity, this liquid is going to behave in certain manner under stress. It's going to come out of a nozzle, it has to. So you will still be adding other chemicals which will be able to control the rheology of this ink. So whichever technology, it still has to pass through and stop. When there is nothing, no push pull, then it stops, and it should not keep dripping. So, if you just say tomorrow, say, well, we use no other chemical, just a dispersion and thing, you might find that you are not able to control. You are pushing, but after that also it keeps coming out. Then it will be difficult. So, you need some control of rheology by using some high molecular weight water soluble polymers. So, this is an additional thing which you may not require after printing, because they are water soluble, so they will be washed off. But during this process, while it is stored, while it is being used during printing process, the rheology control is required. And so, whosoever is doing this formulation must calculate, determine all the properties that you have, and ensure that all such chemicals have some synergy between each other and with the technology of the print head as well. Aqueous based system normally may be there because that is easy. So, just last information for today. So, while we are saying that it is a very specific type of a ink or a pigment which is so specific that everything that you see on a monitor would be correctly reflected onto textiles. So, that is one typical part of it, that is the whole chemistry has to be understood, which is pretty much researched, and not every molecule can do this job. But so you have a pigment dispersion, you can be very happy that I have a dispersion which I am going to be using, is calling it ink, just the viscosity has to be controlled. But one gets surprised that these formulations can have many things. A polymeric binder, as we said, which is the most important thing, and there a type of a binder which is not going to do any choking of the nozzles and the print head is a good amount of research input. Of course, for water or aqueous based inks, you will have water, which is a dispersion you are creating. In addition to that, they may be using some co-solvents, wetting and adhesion to the substrate. So, it does not go very easily there itself, it stays there, and also for controlling jetting properties. So, additionally, so surface tension control, wetting control, some examples are here, but different companies may like to use different things. So, you have a co-solvent. You may obviously saying dispersion, and so there is a surfactant whose job will be making sure surface tensions are nice. And also when you are not using the printer, what is happening? Ink is still inside. You are not allowed to very easily dry when you are not printing, because otherwise again you have to do cleaning. So, normally what would happen is that when you stop printing, the underside of the head is cleaned automatically, not dependent on whether the person who is in charge remembers or does not remember. So, that is one cycle which has to be done. So, that the underside is clean, inside of course is liquid thing. So, that part is there. So, surfactants may be there to do various job. Humectant also may be there, so that again for similar purpose, to make sure that while the surface surfactants are doing dispersions, controlling surface tension and so on, so humectant will keep providing enough moisture, so drying does not take place again. Now, this is outside, this is inside the ink and not on the fabric. So, that means you are now finding so many things are being added. So, this formulation is not simple. Then you may add an anti-foaming agent, some silicon based systems or otherwise, or some polymeric based system, because at the frequency that you are talking about, in case there is anything which is a surfactant also is there, and there are foam or any such thing generates within the small chamber also, then transfer of the so called force for ejection purposes may not be doing the job right. So, this is pretty nice. It is quite possible that one chemical may do both the jobs, like if you have a large molecular weight molecule, it can act like a surfactant and also maybe act like a antifoaming also, but you do require something, whether a separate chemical like a silicon based chemical or any other chemical, that you will require that. So, viscosity control agent means again some solvent maybe additionally there, which would also mean a polymer could be there. Again we are saying it is a low viscosity system, but you still have to control the viscosity, and maybe a biocide means you may want the ink to be stored for months together. So, whatever you can have aerobic or anaerobic growth, which you must not have. So, while this type of a thing may be required for a normal printing process also, but there you are looking within a week you will be able to finish it off, you know. Here you may say, well, no, somebody has made the ink and expect the storage there and you will keep using, whatever your strategy may be there. And it must be, everything must be so they are all in sync, that the technology that you are using, they do not interfere with that, and so everything is so very carefully selected, and its purity also has to be.
In the most of the case, when we are using natural thickness, biocide is must.
Right. So, the question that was is that here that biocide, for example, tomorrow I decide, well, I will use some copper compound in a normal thing which will be washed off later, you can use it, or another compound which is very effective, a cationic agent which is effective biocide, large molecular weight, does not matter. But here function may be same, the durability required is much larger. The printing paste that you make invariably, you may not finish in a day, but at least within a week you will be finishing. Here you are looking at maybe 6 months to 1 year. So, requirements are very different. So, there we are, we stop here and we will pick up next time when we meet this type of ink and further other inks.